Hello and welcome to this video on derivatives. In this video I'll show you what a derivative is, its definition, we'll derive it mathematically and prove that the derivative of x to the n is nx n to the minus 1. Then I'll show you the derivatives of other elementary functions that pop up all the time and are important to know, before finally ending by showing you the different ways that you might see a derivative written on the page. Let's start with the definition of what a derivative is. A derivative is defined as the rate of change of a function with respect to a variable. We can show this mathematically. So if I get a set of axes, here's my x and y coordinate axis. If I draw a function of x, label this fx, and label a point on the function, to find the derivative, if we find the tangent at that point, this is dy over dx, that is the derivative of the function at that point. From looking at that, you won't be able to see how mathematically you would write it down, but I'll show you how you can. I'm going to label a second point that is a distance h away from the first point. So I'm going to label this point as x plus h. Now I'm going to draw a line that connects these 2 points, also known as the secant line. We can write the equation of this line mathematically as x plus h, which is the second point, minus the first point, over h. However, this isn't the tangent of point x, but as h gets smaller and smaller and smaller, we're getting ever closer to the tangent of point x, which is what we want. Mathematically, we can write this as dy over dx, or the derivative, is as the limit of h goes to 0, so as it tends towards 0, it will get closer and closer to the tangent line. This is described as the mathematical definition of a derivative. Knowing this, if our function is x to the power n, we can use the mathematical derivative definition to find what the derivative of x to the n would be. And that's what we'll do right now. This is how to mathematically derive the derivation of x to the power n. To begin, I'm going to rewrite out the definition if the function is x to the power n. That would look like this. Using the binomial power series, I'm going to write an expression for x plus h to the n. And so on until you reach the end of the series where it's h to the power n. If we sub this expression into the definition above, we can make some cancellations. I'm now going to take a factor of h out of the final terms, just so you can see how the equation will be affected as h tends to 0. My factor of h. This is an optional step. You don't have to do this step, but I'm including it just because it will make it easier to see what happens, like I said. As h tends to 0, everything inside the bracket here is just going to be 0. Therefore, the differential for a function x to the power n is nx to the power of n minus 1. This is our first elementary derivative. Now I'll show you a few more elementary functions and their derivatives. The ones I'll show you are ones that you should know, or that would be very useful to know because they are very common and they crop up all the time. If our function is just a constant, denoted here by the letter a, then its derivative is just 0. If our function is in the form of x to the power n, its derivative would be nx to the power of n minus 1. The function ln x, its derivative is 1 over x, and for the function e to the x, I'm going to put a constant there as well. Then its derivative would be a e to the ax. If it was just e to the x, then its derivative is literally e to the x. For the trig functions, all you need to remember, sine will differentiate to cos will differentiate to minus sine will differentiate to minus cos, and minus cos will differentiate to sine, and it will carry on going and going. Drawing this circle will help immensely. I recommend that you remember the differentials of these elementary functions because they crop up a lot, especially in physics. Before I end the video, I'm going to show you the different ways that you can write down the derivatives. In this video, we've already seen a few different ways of writing down a derivative. We've seen dy by dx, and we've seen f dash of x. There are a few other ways that we can write down or denote that something is a derivative, or that you need to find its derivative. I'll begin with a function. You could also write this as y equals, and then it's the variable. There are a few ways that you might see the derivative expressed. So as we've seen in the video before, the first derivative can be expressed as f dash of x, but it could also be expressed as y dash, and this is the same as dy over dx. And it's very similar when it comes to the second derivative. Instead of f dash, it'll be f double dash. Same with y dash, it'll be y double dash. And for the second derivative, it's d squared y over dx squared. That just denotes that you've differentiated with respect to x twice. That's why y isn't squared, but x is. It's because you've differentiated with respect to x. One thing that you might see, it's not common, but I'll go through it just in case you do. Sometimes you might see a number or a variable in the brackets. That just means you need to find the derivative of the function and then evaluate it at that value. So for this example, the first derivative, find the first derivative, and then evaluate it at 2. So if the function was x squared, then the first derivative would be 2x. So evaluating that at x is 2, it will be 2 times 2. So the first derivative of that evaluated at 2 would be 4. There's one more thing I'm going to mention before we wrap the video up, and that's for when you are deriving with respect to time. It can have its own way of writing it, it's just a different way of writing it, but it is exclusively only to time derivatives. If you do derive something with respect to time, instead of y dash, it would be y dot. Everything else will be the same, it'll just be dt at the bottom for the fraction because it's with respect to time. And for the second derivative, instead of y double dash, it will be y double dot, and everything else will be the same. Just swap the x for t because it's with respect to time. So that about wraps this video for today. I hope it's been helpful, and if you do have any questions, feel free to post it in the comments below, and I'll try and answer as quickly as I can. So with that, thank you for watching, and please subscribe if you found it helpful.